The Biomechanics exhibit was about 5 years in development and involved a very large team of people. So I organized a group of scientists to provide ideas and some of the research behind biomechanics of different kinds of animals and plants, from flying birds to swimming fishes and running humans. And there was a big exhibits team at the Field Museum and at the Denver Museum of Science that got together with the scientists and developed the exhibit content. And together it was a great team that worked really hard for about 3 years to produce this.
So this exhibition is divided up into 7 sections. It focuses on the structure, the way in which living things are able to support themselves and resist the forces imposed upon them by their environments. It looks at heat exchange and how living things are suited to stay warm or to stay cool. It looks at how living things circulate fluid, be it blood in our own body, and the various strengths that a heart needs to be depending on the animal it's in. And the section we're standing in now looks at the strength of a bite and claws. It looks at how teeth are specialized and how the shape of a jaw is specialized for what that animal needs to do. It's a very exciting exhibition that goes through all the different aspects of the structure, the strength of the different parts of living things and how nature has developed those for the animal's survival.
The exhibit has a lot of interactive elements to it to encourage people to reach out and grab something or to interact directly with the principles of physics or engineering that are part of biomechanics. This, for example, is an exhibit on how lever mechanics works. So my arm is a lever pulling up on the lever mechanics interactive exhibit, so you can see how forces change when the muscle attaches close to the joint, like ours, or farther from the joint, like the joint of a digging mole, which has very high digging forces. Another part of the exhibit is our creative video theater here on temperature. So this is the heat theater, and it highlights the many ways that animals thermoregulate, how they control their temperature, both in cold environments and in desert, hot, dry environments, and how they maintain their temperature under those conditions.
So just to introduce you to one of the specimens that's been installed here that you can come and examine is the duck. Now, the reason why I think that this is a really exciting exhibit is it looks at something that's really cool that has evolved within the duck's feet. So imagine you have a cold body of water and you stick your toe into that water. Well, your blood circulates, and so as it gets cold, all of you chills down, and so you feel that chill. Well, not so with the duck. The blood still circulates, but what it has is built into its leg, there's a heat exchanger. If we were talking engineering, we'd say a liquid-to-liquid heat exchanger. The way that the blood circulates is the warm blood comes in contact with the cold blood, so on the way down it cools off, and the blood on the way up warms up, so the heat isn't lost in the duck's feet while it swims in the really cold water. How neat is that? And it's amazing when we look at things like this all throughout the natural world, we're actually able to take some of that that nature has created and say, how can we apply that in our own world? And so you'll see in this exhibition a number of different ways in which science has grabbed onto what's happening in how a species, how an animal might have adapted to survive a particular environment and use that for solving our own problems. We call it biomimicry, or copying, mimicking that which has happened in the biological world. Very exciting and very cool.
People are infatuated with these legs because they can't get them and they don't understand them. How do you feel when you actually run on them? Well, these are the Oser, as you know, the Oser Flex Run, and it's not like slapping them on, and it's like you got feet again. They are a piece of sporting equipment. It's a piece of freedom.
Hello, Osimo.
Hello, Tiffany. It's nice to see you.
It's nice to see you too, Osimo, and I am so excited to be here at the Ontario Science Centre with you. Now with each step, Osimo must adapt and constantly counterbalance using all its sensors and computing powers to remain upright, adjusting all along the way. Way to go, Osimo! One thing is for sure. Today, Osimo is the world's most advanced step in innovative mobility.
Thank you very much.
Another really fun interactive is the heat camera, which provides an image of yourself standing in front of it with the temperature of your skin and your clothes shown in purples and yellows and reds. It's a very popular way to look at temperature, to look at how your body gives off heat, and to get a really good selfie.
This is a model of the Dunkleosteus, and it's an extinct animal. I hope I pronounced that right. And it was what came about was this question of, well, how strong was its bite? And so what researchers did is they built a physical model of it, and then they tested that model, and they were able to do the math, and they realized it had one of the strongest bites ever. Able to bite through the video. As you watch it, you'll see them testing, and they're biting through a whole chicken, and they're biting through a can, and it's just an incredible bite. And it all comes down to the way the jaw is structured. The way the jaw evolved to have the 4 particular bones and the ligaments that attach them, the muscles, the way that the muscles were able to contract, that motion of that physical structure was able to apply an incredible amount of force on its teeth, on a small surface area. So just an incredible way of concentrating force and energy into a single deadly bite.
The giraffe heart interactive is one of my favorite. Here we have an actual giraffe heart in a jar. They're very big, and their walls are very thick to be able to pump blood all the way up to the top of the head of a giraffe. The interactive part is on the other side here, where the kids can pump the blood themselves all the way up to the head, and you can see how many pumps it takes of the little pump to get the blood all the way to the head of the giraffe. So lots of fun.
Biomechanics, the machine inside, is an amazing exhibition for all ages. You'll find that there's a lot of depth if you want to read and examine all of the incredible content that's available. There's some fantastic specimens that you may not get a chance to see elsewhere, and a few very key and enjoyable interactives in which you can engage and participate in understanding, again, that machine within, the way in which the structure of the human body, as well as all of the various animals and specimens we explore here, of how the body works and how the strength of it comes from its shape, its structure, the way that the muscles work. It's just an amazing exhibition that all ages, all visitors should enjoy and get something out of.